Choosing the right EC2 instance type can save you hundreds of dollars every month. In this video, I'll break down each instance family with real-world examples, so you'll know exactly which one to pick for any workload. Before choosing an instance, it's important to understand how AWS names them. Let's take an example. M5.x, large. The first letter represents the instance family. In this case, M stands for general purpose. The number 5 indicates the generation. Newer generations provide better performance and efficiency. Finally, X large defines the size. This determines CPU, memory, and network capacity. Instance sizes scale from nano and micro, all the way up to multiple X large variants. Once you understand this naming structure, you can quickly evaluate any EC2 instance type without needing to memorize everything. Now let's look at the main EC2 instance families and when to use them. General-purpose instances, like the T&M series, offer balanced CPU, memory, and networking. They're ideal for web servers, development, and small databases. T-series instances are burstable. They build CPU credits and use them during spikes. Compute-optimized instances, like the C-series, handle CPU-intensive tasks such as batch processing, game servers, and ML inference. Memory-optimized instances, like the R, X, and Z series, are designed for high RAM workloads like Redis or SAP HANA. Storage-optimized instances, like the I, D, and H series, provide fast storage for heavy read and write workloads. Finally, accelerated computing instances, like the P, G, and F series, use GPUs for machine learning, rendering, and high-performance computing. Knowing these families makes choosing the right instance much easier. One important EC2 concept is the difference between burstable and compute-optimized instances. T-series instances are burstable because they use CPU credits. They earn credits during low usage, then spend them during traffic spikes to temporarily boost performance. This makes them cost-effective for small websites, APIs, dev environments, and testing servers. But once the credits run out, performance is throttled during sustained high CPU usage. Compute-optimized instances, like the C-series, work differently. They provide consistent CPU performance all the time, without relying on credits. That makes them ideal for analytics, gaming servers, video processing, and machine learning inference. The key takeaway is simple. Burstable instances are best for lightweight or unpredictable workloads, while compute-optimized instances are better for continuously CPU-intensive applications. Before we begin, here's a quick overview of the hands-on demo. First, we'll install the stress utility on a T3 micro instance and configure a CloudWatch dashboard to monitor CPU usage and CPU credits in real time. Next, we'll run a stress test on the burstable instance and observe how CPU credits are consumed under sustained load. Then, we'll repeat the same test on a C5 large compute-optimized instance to compare fixed performance behavior. Finally, we'll analyze both results side by side to understand when to use burstable versus fixed performance EC2 instances. Now, let's see the difference in action. I've already launched two EC2 instances, a T3 micro burstable instance and a C5 large compute-optimized instance. First, let's connect to the T3 micro. I'll open the instance details page, copy the public IP address, and connect using SSH from the command line. Now that we're connected to the EC2 instance, let's install a utility called Stress. Stress is a lightweight Linux tool used to simulate CPU, memory, and system load. It helps us intentionally push the instance under heavy workload so we can observe how the server behaves under pressure. Let's set up a CloudWatch monitoring dashboard so we can observe the burstable behavior in real time. Once you're in the AWS console, search for CloudWatch and open the first result. Open the Metrics section, then click on Explorer. From the resource types, select EC2. By default, several metrics may already be displayed, so let's remove those. We'll select CPU utilization, CPU credit usage, and CPU credit balance. Next, in the Filter section, set Instance Type to T3 Micro. Under Graph Settings, change the period to 1 minute. For better visualization, set the layout to 3 columns and 1 row. Then, set the time range to the last 30 minutes and configure the auto-refresh interval to 1 minute. Now that our CloudWatch dashboard is ready, let's close additional dialog to have clear view. Now, let's go back to the SSH terminal connected to the T3 micro instance and start a stress test on 2 CPUs for 300 seconds. This will give us a clear view of how the T3 micro behaves under sustained load. The stress test is now running, so let's monitor the instance behavior for the next 10 minutes. I'll quickly fast forward this part. Stress test is completed. Let's monitor for a few more minutes. Let's follow the same process for the C5.large instance. For now, let's go back to Instance List. From the Instance List, open the Details page for the C5.large instance in a new tab and copy its public IP address. Next, we'll connect to this instance using SSH and install the same Stress utility. Now that we are connected, let's begin installation of Stress utility. Now let's modify previously configured dashboard to show data for C5.large by changing the instance type. Now our dashboard is ready to monitor C5.large instance activities. Let's go back to the terminal and start stress test for C5.large. Stress test is in progress, so let's monitor the dashboard for around 10 minutes. I'll fast forward this to save time. Now let's analyze the final results from both instances and understand what these metrics are telling us. At the top, we have the T3 micro-burstable instance. First, notice the CPU utilization graph. During the stress test, CPU usage spikes close to 100%, showing that the instance initially handled the workload very well. But the important part is what happens next. In the CPU credit usage graph, CPU credit consumption increases rapidly as the workload continues. At the same time, the CPU credit balance drops sharply towards zero. This means the instance is consuming all of its accumulated burst credits to maintain high CPU performance. Once those credits are exhausted, the instance begins throttling CPU performance. That's the key behavior of burstable instances. They can temporarily deliver high performance, but only while credits are available. Now let's compare that with the C5 large fixed performance instance below. Here, the CPU utilization graph also increases during the stress test, showing that the workload is running successfully. But notice something important. There are no CPU credit metrics at all. That's because compute-optimized instances do not use a CPU credit system. Instead, the C5 large provides dedicated and consistent CPU performance continuously, regardless of workload duration. This makes it much more suitable for sustained compute-intensive applications. So the takeaway from this demo is simple. T3 Micro is cost-effective and ideal for lightweight or intermittent workloads, while C5 large is designed for stable, predictable performance under continuous CPU load. That's it for this video. I hope you found it helpful and easy to follow. If you did, please like, share, and subscribe for more content like this. Thanks for watching.